Hello, I'm Richard, and this is a video about using Libfuse with Zig. Fuse lets you create and mount a file system in userland as opposed to the kernel. In fact, you can even mount and use the kernel without root privileges. So this opens up lots of possibilities, like if you want to mount a dodgy file system where you don't trust the implementation or the contents of the file system image, then you can do that in userland. Or there's Libfuse, which is a nice project that allows you to distribute SQLite, so you can use SQLite like a normal local SQLite instance, but changes will be replicated to other servers in a cluster. Another use I've seen is using UnionFS, where you have two different file systems and you write to one file system and read from the other file system, and you can do that in userland and get some extra control versus the kernel implementation of UnionFS. And another nice one would be to use it to simply pass through most operations to an underlying file system, but then intercept some calls and maybe trace them or debug them or inject deliberate errors, that kind of thing. So yeah, there's lots of nice things you can do with Fuse, and it's nice to be able to use a language like Zig rather than C. There is actually already quite a nice Go implementation of the kernel interface for Fuse that I've seen, but to be honest, I actually prefer Zig. As nice as Go is, I do like Zig more. Maybe I'm just like a sucker for manual memory management, whatever. Anyway, so how difficult is it to use Libfuse with Zig? I guess the alternative to Libfuse is to use the kernel interface directly. That I doubt that would be too difficult, but it would certainly be more time consuming than using Libfuse, which allowed me to get up and running very quickly. And it's really easy to call C code from Zig. If we go over to the Zig build file, this is a build file for Zig. It's a build file for the project, and it's almost the default Zig build file. I've just added link libc, and I've added link to system library Fuse, which I'm using NixOS, so it's all linked to Fuse in the Nix store. An alternative to this would be to compile Libfuse with Zig, which I did try doing, but Meson didn't like the Zig linker output. And then I was looking at creating a build Zig for Libfuse, but the Meson file in Libfuse is quite complicated, and I'm not sure which parts of that I need to translate to Zig and whatever, so I just stopped doing that, because honestly I got this working very quickly, just linking to the system library. And yeah, if I was going to do something more complex, like actually write a full-fledged file system or something like that, I'd be very tempted to use the kernel interface directly, and then you can make better use of Zig's features. But that's just going to be a much longer project and includes quite a lot of tedious stuff like figuring out how the kernel interface works, and that sort of thing. So then, now let's go and look at the C code. So I just translated one of the examples from Libfuse to Zig, and this is the original C version. You can see it's not very long. All it does is create like a fake file system with one file in it, and in this version it lets you set the file name and the contents, and it implements enough stuff that you can enumerate that file system and read the file contents, but nothing more. And then, yeah, I just made a Zig version of that, which you can see here on the right. I actually cheated a little bit and just, statically set the file name and contents, just because I wasn't that interested in setting up the command line parsing. Okay, so as well as linking to Libfuse, we also need to get its header, which in Zig you can directly include the header file. It actually translates that file to Zig. Instead of doing that, I used Zig translate C and translated the header file, which you can't see the full details of how I did that there, but it is on my website's blog. And yeah, it's really nice being able to do this, because then you get to see exactly what Zig was produced from the C, and you can use this as a reference when you like the C types in Zig are a bit more unwieldy and complicated than Zig's native types, and it's nice being able to see what the actual function signature is for a given function in Zig syntax, so you don't have to go into the Zig documentation and spend time figuring out exactly which type of C pointer or Zig or whatever it's translated something to. You can just see it in this file. Okay, so let's look at the structure, the overall structure of a Libfuse program. It defines a C struct, which includes a list of function pointers that implement an interface. The interface is basically this struct, and this struct is actually quite large, and we don't need to implement most of these functions for our purposes. So most of these fields will simply be left as 0. And you can see that the Zig and C code map quite nicely together, except that on the Zig side we are not directly defining this struct. We're actually using the 0 init function, because in Zig you don't usually, if you want to define a struct variable, then you should explicitly set all of the values in that struct. It's an anti-pattern in Zig to have like a mostly 0 struct. You can still do it using this function, and this function takes the type that we want to create mostly zeroed, and then it takes an anonymous struct which will set some values inside this struct that we want to zero init. But yeah, usually if you're designing a Zig library and you don't want to have large structs full of default values, then just don't create large structs, I guess. Just find some other way of designing that library. But because we're dealing with Zig, we don't have the choice to simply, because we're dealing with C, we don't have the choice to simply just write the library another way. So we have this handy utility function here from Zig standard library. Okay, and then below it we have our main function entry. Our main entry to the program. There's a slight difference between Zig and C, where in C you have these arguments passed to main, and in Zig we don't. We can get these from the standard library. Another difference is that in the C version, you'll note there's some stuff up here about parsing options. I just ignored that, as I mentioned earlier. But so, like, the main difference really that's worth mentioning is that here we're calling fuse main directly, and here we're calling fuse main real, because fuse main is a macro, and Zig can't translate that macro for whatever reason. So we just have to call fuse main real and specify the size of the operations struct that we're passing in. Again, like if you're writing pure Zig, you never have to do something like that. This is just because we're dealing with C, and it's not much of a big deal. Okay, so the first function that I implemented was get attribute, so let's go and have a look at that. There we go. So again, you can see that they're kind of like, if you squint, then they actually look very, very similar, because that's the same code. Where are we? Okay, hello get attribute. Yeah, so still both quite similar. Got more white space in the C version. Yeah, so let's focus on what's different. First of all, again, hello get attribute passes in the stat struct. It passes in a pointer to the stat struct, which is passed back to the user. In Zig we do something a bit different. We don't access this pointer directly except at the end, where we perform a copy. What we do instead is we create a fresh zeroed stat struct, and we set some elements of this stat struct, and then we copy this to the pointer, and Zig has specified this pointer as an optional pointer, so it can be null. Zig distinguishes between pointers that can be null and ones that are never null. I guess C can do as well, but you've got to use attributes, and they don't really work uniformly that well, and they're not the default. So yeah, Zig has sort of enforced some safety on us, and before we can dereference this optional pointer, we have to perform a check that it's not null, at least depending on what our compilation options were. If we compile it as under a safe mode, then this question mark will insert a safety check before we do the copy. And you could access the members of the struct pointer directly, but then you'd have lots of question marks everywhere. So I do the copy in one go at the end, which I think is probably the better thing to do. It makes things more explicit. In the C version, you can see as a memset to set everything to 0. It would be quite easy to forget to do that memset. In Zig, again, because you're not allowed to create a struct which is all zeros unless you use one of these functions, you're kind of making things very explicit. We couldn't just, we could define this st as undefined like this. We could do that, but then it's very clear that you're choosing to make that undefined, and it's visible to somebody that, hey, maybe the stat struct shouldn't have undefined elements in it. It should all be cleanly defined before passing it to the user. Okay. I guess the other difference is that we have this path variable, which is present in all of the functions for Libfuse it seems, and we convert this from a multi-value pointer. We convert that from a multi-value pointer and turn it into a span. And this then means we can compare it. You can use the Zig standard library functions and compare it with other spans. It makes it easier to take another span from that span. The span that we produce here contains the length of the path, so it counts the number of characters in the null terminated string until it reaches null. Then it produces the span which has the length built in, which is really nice. In C, null terminated strings are just like a massive mistake. They really are like awful. They're probably one of the worst aspects of C. I doubt there are many modern languages, if any, that use null terminated strings. Of course, you can use them in Zig. It allows that, for like the small number of edge cases where you need them, like just dealing with C. But it's nice to turn it into a span and then use it with the standard library functions. Okay, moving on, what have we got next? We've got read directory. So when we call ls or whatever, this is what helps enumerate the directory. And we have like the standard directory entries here, like the dot and the 2 dots to go back to the previous directory, and the file name of our one and only file. And Libfuse provides a function pointer that it passes into read directory, and a buffer which presumably the directory entries are written to. And we can call this filler function and add our items to the directory. You'll notice that in the C version it's just ignoring the return value of filler. In C, you can make it so functions, you have to pay attention to their return value, but again it requires adding an attribute to the function. In Zig it's the default. If you want to ignore a function's return type, you have to make that explicit by setting it to an underscore. So it's quite clear then that somebody's ignoring something. Here I chose not to ignore it and just to see if there was an error. I'm not really sure of the correct way to check for errors from the filler function. I assume that the buffer can run out if you add too many items and stuff like that. So it is kind of good to check the return value of that function, and you can see that Zig's kind of enforced a little bit of extra safety here versus the C version. Although it probably doesn't matter in either case because there's only 3 items in the directory. But whatever. What else? Okay, that's it for that one. Moving on to open. Yeah, the open function correlates with the open syst call, except that the open system call returns a file descriptor. We don't create a file descriptor or track file descriptors. I assume the kernel does that, and the Fuse doesn't have much control over file descriptors. All we do is check that the file can be opened. I suppose we could do other things as well, but yeah, all we do here is check the file can be opened. We check that the access mode is read-only, and probably the most interesting thing about this function is that we need to access file info so that we can get the flags. And you can see here I've defined my own file info struct, because if we go to the auto-generated one, you can see that Zig refused to automatically generate it because it's got bit fields in. So Zig can't handle bit fields, and if we go to the C version, we can have a look at what a bit field is. So these elements of the struct, which have a 1, a colon and a 1 after them, these are single bit items in the struct, and they're basically Boolean values, and C lets you specify the exact number of bits in a field in a struct. Which so does Zig. Zig also has bit fields in structs, but Zig has well-defined bit fields, and when you define a bit field in a packed struct in Zig, it'll be the same layout on all targets. Whereas in C, you can get different layouts on different targets. So, I mean, in this particular case, it looks like the author of Libfuse has taken into account that you can end up with different layouts and has actually added 23 bits of padding, which I assume takes the padding up to a storage unit's boundary or an alignment boundary. So presumably, you know, with this particular struct you won't get any padding added, but let's say if like these two areas of padding didn't exist and you just had these how many is that? I'm going to go with 9 bits. Let's say this, like these 9 bits of bit fields were here without this padding, and then you have this 64-bit int. There's probably going to be some padding. There's probably going to be about 23 bits of padding, or maybe less, just to take it up to a 2-byte or a 4-byte boundary before we start the file handle. Otherwise, the CPU is going to have to do some extra work to dereference this file handle value, if it can at all. You know, depending on the platform, some CPUs, they don't allow you to actually address individual bytes and stuff like that, or you know, certainly don't allow you to address individual bits. So yeah, the C compiler has quite a bit of freedom in where it adds padding around a bit field, and there is actually a plan by the Zig developers to figure out all the different padding that C can add for different platforms so that it can translate bit fields, but it's not been added yet. But in this case, we can just define our own type and cast to that type. I mean, in this particular case, all we want to do is get the flags property, which is at the top of the structure. So in this particular case, we could even just cast the pointer directly to a C int, and we'd probably be fine. But for some reason I just defined the whole struct. Can't remember why. Probably because I didn't think to just cast to an int. And probably we can also define the bit field in its full complication if we wanted to. It'd probably work in this particular case. But that's actually sort of the main concern I'd have about using Libfuse for a bigger and longer project, because eventually you might need this bit field and then have problems with it, and then, you know, something that was relatively simple could get a bit more problematic, to use a problematic word. Okay. Right, so where were we? We were on open, I guess. Yeah. Next up is read. So this is the final bit. You'll notice, I mean, if you done a lot of systems programming, you'll notice that the first thing in read is actually path rather than the file descriptor. The file descriptor is passed in. It's actually passed in this struct that we're just discussing earlier, which you may have seen earlier. But it passes in path first, which I assume is just for convenience sake. All of the functions seem to take path first. And yeah, we just return the static file contents if the file name is correct. There's not too much different than from before. Zig again enforces a little bit of safety by making sure that all of our integers are the same size. So we have to cast offset to U size, otherwise we'd have to cast everything else to C long, which is what offset is. Interestingly, offsets are signed values, so they can be negative in theory. In practice, they should never be negative when passed to read, if I remember correctly. I could be wrong about that. But yeah, C adds a bit of safety checking here. If we did somehow end up with a negative offset, it would catch this, and we wouldn't have to worry about getting weird results and out of bounds reads and writes if somehow a negative value got in there, like from an overflow, something like that. And yeah, otherwise this is not too different from the C version. Again, using slicers, which were converted from a C pointer, so the safety effects are somewhat limited, but you kind of have this point where it gets converted to a slice just here, and then from on. So say if this function was more complicated, and then after this point where you convert it to a slice, you sort of have this safety checked bit where it converts it, and then you shouldn't get problems after that point. Although of course you don't know how long buffer really is, I suppose, if the size that's passed in is wrong or something like that. But yeah, you sort of have this nice safety boundary where you go from C to Zig. I think that's it, basically. Let's demonstrate this. So, to build and run, we can just use Zig build run. And after the double, if you look at the double dashes here, after this we're just passing these arguments directly into the Libfuse library, and it just tells it to run in the foreground with F and to mount our file system at this location. Okay, so that's now running. Let's go to a different terminal, and we can ls that, and you can see that the date is set to 1970 because we didn't bother setting the timestamp on that directory, and a bunch of other stuff is just the defaults basically. And on the right hand side you can see that we received a stat call and read dir into stat hello, which was done by ls, and then we can read the file. Yeah, you can see that's the file contents on the left, and on the right you can see that Cat's used a buffer of 4096 bytes to make that read, probably, or Libfuse used a buffer of that size. And there you go. That's how it works. So, I have an article on the same subject, again at richiejp.com. I'll post that in the YouTube description. Yeah, that's it. Thanks for watching right to the end.